Today's video is going to go over how to use the data that we collected in the heart rate response to exercise lab so that we can use the ability to have this kind of predictable response of heart rate and use that data to get an estimated VO2 max. Again, this is very key for two reasons. One, there's a large population in the US that really can't go to VO2 max, and so therefore it's best to estimate it. And then of course the second reason is that just the equipment in order to measure that can be very expensive and not readily available, or have the ability to kind of take it out into the field to do that type of research. So what we can do is we can use, like I mentioned, this heart rate to kind of get a good prediction. We can use metabolic equations to put in how much work or power the subject is doing, and then get estimated VO2 for that work rate, and then heart rate, and then use that to predict VO2 max. And I'll show you exactly how to do that. So this is the sheet that you guys should be working off of for your lab. We'll work through at least the top. So here we'll look through our subject's age, 30. This is a male who weighs 90 kilograms. We know how to calculate the estimated heart rate max, which we know is 220 minus age. So therefore we can calculate this as 220 minus 30, which gives us an estimated heart rate max of 190 beats per minute. As we talked about in the lab, the heart rate range that we're going to try to use for this is the validity of the prediction really goes down below about 55% of the heart rate max, and then we don't want, and since this is a submaximal test, we want to end the test at about 85% of heart rate max. So therefore we need to fill in a range here. So to do that, we'll take our age predicted heart rate max, which is 190. To get 55% of that, we'll multiply it by 55% as a decimal, so 0.55. 190 gives us 104.5, and then to get 85% of that, we'll multiply 190 times 0.85. Gives us 161.5. So that's the range of values that we're going to be looking at in the test. So now if we move on into the data collection, this should match what most of you guys have for the data you collected. So we have the time of each stage. Each stage was 2 minutes. We then have, for this example, we're using the bicycle ergometer, so we have the number of revolutions per minute that the subject was pedaling. Again, we kept that constant at 50, and since this was a male, we added 1 kilogram every 2 minutes. You may also have this in watts, and so you can convert watts into kilogram meters per minute by multiplying that by 6, or we can go back and use our formula: power equals resistance times 6 times RPM in order to get this. And why do we need it in kilogram meters? Because if we look back at our equation that we're going to use to calculate estimated oxygen consumption, this power or work rate needs to be in kilogram meters per minute. So we'll calculate for each of these. So resistance, power equals 1 times 6 times 50. Gives us a power output of 300 kilogram meters per minute. And we'll continue to do that for all the examples. So here, power is equal to 2 times 6 times 50. Gives us 600. Power equals 3 times 6 times 50 for this example. It's 900. And last but not least, 4 times 6 times 50. Again, 4 kilograms times our 6 meters per revolution times 50 revolutions per minute that we were doing. gives us 1200 in this case. Okay, so now that we have our work rates, what we can now do is go in and plug in these work rates into the ACSM metabolic equations, and that's how we fill in our estimated VO2 column here. So we'll do this for each stage. So here's stage 1. Estimated VO2 is equal to 7.0 plus 1.8 times work rate, which again, as I mentioned in class, isn't optimal. What we're really talking about is power in this situation. ACSM just uses the term work rate, so we'll plug in our power number for stage 1 is 300 divided by body mass, which we can get from here, which is 90 kilograms. So if we then multiply these out, remember back from good old algebra, please excuse my dear Aunt Sally, we'll start in the parentheses. So we'll do 1.8 times 300 divided by 90 plus 7. So we get 7 plus 6, which gives us an estimated VO2 equal to 13 mils per kg per minute. And we'll work our way through each stage, and I'll go ahead and do that now. Stage 2 is the same formula, again, 7 plus 1.8 times 600 in this case, divided by body weight, which is 90. Again, we'll start in the parentheses, 1.8 times 600, something happened. 1.8 times 600 divided by 90 gives us 12 plus 7, which gives us 19. So estimated VO2 in stage 2 is equal to 19 mils per kg per minute. Stage 3, same equation, 7.0 plus 1.8 times 900 divided by 90 gives us 8 times 90 gives us 18 plus 7, 5. So estimated VO2 in stage 3 is 25 mils per kg per minute. And then finally stage 4, 7.0 plus 1.8 times 1200 divided by 90 gives us 24 plus 7 gives us 31. Okay, so now that we've calculated all these values, we'll move them over into our chart here. So stage 1, estimated VO2 is 13. Stage 2 is 19. Stage 3 is 25. And stage 4 is 31. So again, that's how we can use these metabolic equations to figure out essentially the estimated oxygen consumption at each of these stages. Okay, so once we have that calculated, now we can start to get our predicted VO2 max by plotting these points in the graph paper provided. If you need more graph paper, there is a PDF that you can just print out in Blackboard in this week's modules. Okay, so as we get ready to get started, one thing that we need to remember is that, as I briefly mentioned earlier in the video, is our validity goes up in this because goes up for using this prediction model if we use heart rates that are above 55%. So and below 85%. So if we'll look at our range, again, our range is 104.5 is 55 to 161.5. So when we get ready to plot this, we want to leave out plotting any points that are outside of that range. And we'll look, our first point, our heart rate of 96 is less than our 55, our 161, just in that range. So we are only going to plot these 3 data points. We're going to exclude the one that is less than 55%. So we can go to our graph paper. Just a little bit here. So in our graph paper, some students I've noticed have a little bit of problem of actually making their X and Y axis. Again, we're going to plot our estimated oxygen consumption on the X-axis and our heart rate on the Y-axis. So when you're thinking about what your how to set your tick marks and what you need to do, one, as you can see here, I don't actually start at 0, I start at 80. Again, you want to start below any points that you might have, but not necessarily start at 0. And then you want to go above and beyond any values that you might expect. We know that our max heart rate in this case is 220 minus our age, which was 30. So our maximal heart rate is going to be 190. So you see I went to 210 just to be safe. We can use our estimated VO2. Again, this is just kind of using knowledge and critical thinking skills that you've done, but for the most part, we'll look to keep it 55 or below. You can continue it. You see I still have a little bit of room to keep going in case we had a really highly trained subject who had a high estimated oxygen consumption. Okay, so I'm going to begin to plot these points. So the first point that we will plot is an estimated oxygen consumption of 13. So that's 12.5, so that's about 13. Oh, sorry, I'm not going to plot that point. That's less than our range. So I'm actually going to go to our next point, our estimated oxygen consumption of 19 with a heart rate of 110. So we'll plot that data point there. We'll move to our next point, which is an estimated oxygen consumption of 25 with a heart rate of 137. And finally, we'll go to an estimated heart rate of, our estimated oxygen consumption of 31. And we will then plot the heart rate. Seen here is 161. Okay, so there are our 3 data points that we have plotted. And to find my ruler. So now what we want to do is draw kind of a line of best fit. The line won't necessarily go through every single point on this graph, but it should, kind of be somewhere in the middle, maybe an equidistant from above and below. So I'm just going to kind of eyeball this. It doesn't have to be perfect. When you draw the line, you want to go to the top of your graph and all the way to the bottom. So again, there's my estimated line of best fit. Okay, so now what we do is we know our age predicted heart rate max. Our age predicted heart rate max in this case was 190. So we can draw a dotted line there to know that's the maximal value that we could reasonably expect to obtain based on our age predicted max. So this prediction equation uses the assumption that your VO2 max occurs at your maximal heart rate. So then to get what we would estimate our VO2 max would be then to draw a line on where these 2 points intersect right here. So here's the intersection point. So now we want to draw a line of where these intersect. And here's our intersection point. So I would estimate based on this graph here, actually kind of zoom in just a little bit to get a better idea of where we are. So I would estimate this, so this would be 37.5. So I would say, based on eyeballing this, that the estimated VO2 max is equal to, we'll say 37 mils per kg per minute. Okay, now let's do another example. So let's now do one using data from the treadmill. We'll work through the same procedure that we just worked through. In this situation, the subject age is 29, weight is 72 kilograms. Estimated heart rate max, again, 220 minus the age is 29, which is 191 beats per minute. Let's calculate our heart rate range. Again, that's the peak heart rate, 191 times 0.55 to get the lower boundary of 55%. We'll just go with 105 around there. And then to get the upper boundary of 85%, we'll do 191 times 0.85. Gives us 162. Again, we'll round there. So 105 to 162. And again, this is the treadmill example. All right, so now we need to go in. Again, this is data that you should have. If we take a quick peek at what our equation, what we're going to need our speed in meters per minute and our grade in a decimal place. So in this situation, I have our speed in miles per hour. Just to make it simple, in general, I think I told you this, but for most exams and quizzes, I will give you speed in meters per minute. But of course, for this example, the treadmill in the lab gives us miles per hour. So how do we convert that? If you remember, 1 mile per hour is equal to 26.8 meters per minute. So then to calculate each of these in each stage, all we have to do is multiply the miles per hour times that number. So for example, in stage 1, 2.5 miles per hour times 26.8 gives us 67 meters per minute. And we'll follow that. So 2.7 times 26.8 gives us 72.36 meters per minute. 3.2 times 26.8 gives us 85.76 meters per minute. And finally, 3.5 times 27.8 gives us 93.8 meters per minute. We'll just transpose these values here. So 67, 72.36, 85.76, and then 93.8. Okay, so now we have the numbers that we need to plug into our equation. to get our estimated oxygen consumption. So let's go ahead and work through those quickly. So for stage 1, our estimated VO2 is equal to 3.5 plus 0.1 times our speed in meters per minute, 67, plus 1.8 times our speed, 67, times our grade in a decimal. So this is 8%, so we're going to multiply it by 0.08. Again, we'll do our parentheses in first, and you'll see how I work this, but I recommend solving each parentheses first and then adding them all together. So 0.1 times 67, we'll just move the decimal place. So this one's easy, 6.7. And then the next one, 1.8 times 67 times 0.08 gives us 9.6. I'm going to round to 9.65. And then we'll add up the three values. So 3.5 plus 3.5 plus 6.7 plus 9.65 gives us an estimated VO2 of 19.85 mils per kg per minute. And we will continue to do that. So stage 2, in our example, is 2.7 miles per hour and 10% grade. So again, 3.5 plus 0.1 times 72.36 plus 1.8 times 72.36 times 10% or 0.10. Again, we can add these up, 3.5. Again, you can type this into the calculator or you can just move the decimal. 0.1 times 72.36 gives us 7.236 plus 1.8 times 72.36 times 0.10 gives us 13.02. We'll add those together. 3.5 plus 7.2, I'm going to round that to 24, plus 13.02 gives us an estimated VO2 of equal to 23.76 mils per kg per minute. Next up, stage 3. Stage 3 is 3.2 miles per hour, 12% grade. So we can type that in as we go. 3.5 plus 0.1 times 85.76 meters per minute plus 1.8 times 85.76 times 0.12 for the 12% grade. So 3.5 plus, I'm going to do the short way, 8.576 plus 1.8 times 85.76 times 0.12 gives us 18.52. And then we'll add those three together. 3.5 plus 8.576 plus 18.52 gives us an estimated VO2 of 30.60 if I round that to 2 decimal places. Last but not least, stage 4 is 93.8 meters per minute and 13% grade. plug that into our formula here. 3.5 plus 0.1 times 93.8 plus 1.8 times 85.76 times 0.13 for 13% grade. 3.5 plus, move the decimal one place, plus 1.8 times 85 point, sorry, I typed it, add a wrong number, 93.8. Repetition got me. All right, 1.8 times 93.8 times 0.13 gives me 21.95. We'll add those three values together. 3.5 plus 9.38 plus 21.95 gives us an estimated oxygen consumption of 34.83 mils per kg per minute. Okay, let's move these values then into the sheet that you're going to turn in for your homework. Stage 1 is 19.85. Stage 2, 23.76. Stage 3, 30.60. And finally, stage 4, 34.83. All right, so now we have all the data that we need to plot. But first, before we go, let's make sure that, or let's identify which points we're going to plot. Here, if we look at our range needs to be between 105 and 162 beats per minute. If you look, 115, 127, 142, and 160 are all within that range, so we're going to plot all 4 of these data points in our graph. So let's do that. We move to our graph paper. Again, I'm using that same scale that I used before, 5 to 55, 80 to 210. Let's take a look at our data points and go ahead and plot them. So, since we're plotting all 4, we'll begin at the very first one. So, estimated oxygen consumption of 19.85 with a heart rate of 115. Disregard that point, I was off. In our next example, our next stage, 23.76. This is 22.5. I'll say right about there. And a heart rate of 127. Stage 3. Oxygen consumption of 30.6 and a heart rate of 142. And our last point, 34.83 and a heart rate of 160. All right, so now we have all 4 points plotted. Again, you can kind of see that they aren't in necessarily a perfect line, so we'll just kind of get a line of best fit here. And just using your eyes a little bit, draw a line all the way, top to bottom of the graph. So you can see in drawing this line, I went ahead, I got just above this point, just below this point, below and above. So it's kind of right in the middle of everywhere. All right, if we go back to then estimating our maximum oxygen consumption, again, under the assumption that we reach VO2 max at our age predicted heart rate max. Our age predicted heart rate max, 191. So we can draw dashed line. At about 191. And we'll draw where this intersection point is. We will then draw our estimated oxygen consumption. And then if we zoom in, you can see that this estimated oxygen consumption here is probably going to be, I would estimate, about 46. To maximum of 46 mils per kg per minute. Okay, so I hope this video helps you guys analyze your data, gives you a chance to walk through it nice and slow and follow through the way I did it. As usual, if you have any questions, comments, or concerns, feel free to stop by my office or send me an email, and I'll do my best to get back to you quickly and answer your questions. Good luck on your homework and filling this out. And as you'll remember, this will count for 50% of your quiz grade next week. So turn this in at the beginning of class, and you'll get 25 points, assuming that you followed these instructions correctly and did it right and get 100% on this. Then you would get the 25 points out of the quiz, and the rest of the questions will only be worth 25 points. So good luck with that, and let me know if there's anything I can help you with.